Let's examine how we can create a sequential data set and specify the values that we want for its characteristics. In this example, we're going to again be using our TSO ISPF environment, and in this environment we're going to be dealing with the panel for the dataset utility function. In this particular case, you can see where we have the ability to allocate data sets, we can rename data sets, we can delete them, we can display dataset information. Basically what we have here is we have the mechanism in order to be able to manage our data sets, whether we create them or we want to simply get information about them. In order to allocate the data set, I simply specify an A on the command line, and then I come down here in order to assign a name to that data set. In this case, I'm just simply going to call it new.dataset, which in turn, when I hit enter, the system is going to add my TSO high-level qualifier to that name. This is a default option within the TSO environment so that when you create a data set, it will automatically add your user ID as the high-level qualifier. The benefit to this is that it ensures that when you create data sets, then under your high-level qualifier, you don't have to concern yourself with different security rules or access requirements with respect to being able to get at data sets that you've created. In this particular case then, you can see the values, some of them are already filled in, and the ones that we normally leave blank are going to be these at the top, because what we want there is that we want to simply take the system defaults, or we want to use the system administration capabilities that are there in the event that the installation has certain standards that they want to enforce. In the space units, this is where we would indicate the units that we want to allocate our space in. In this case, you can see we have cylinders already specified, but we could in fact specify blocks or tracks or any number of other values that we wanted. In our example, what we were interested in was that we wanted 6 cylinders, and so I can come down here to my primary quantity and I can specify 6 there to indicate that that's how many cylinders I want allocated. On the row for the secondary quantity, this allows me to specify the number of cylinders that I would like to have as a secondary allocation in the event that I expect the data set to expand. The directory blocks will be 0 for sequential files, and then the record format indicates a fixed block format. In this case here, the fixed block is going to ensure that we block the records that we have, and the individual record length is 100 bytes, as we used in our example. Coding a block size of 0 indicates that the system is to calculate the optimum block size for this particular record. The dataset name type is also left blank, since for sequential files we don't have to specify anything. Now that I have all of the information filled in, I simply hit the enter key, and I can see in the upper right hand corner where the system has issued the message indicating that the dataset has been successfully allocated. By hitting the enter key again, we have a blank then on our command line, so we can get the information now to see what the attributes of this particular data set are. So when I hit the enter key, you can see there's my data set name up here at the top. You can see the volume serial number, the device that it was assigned to. You can see the device type that was assigned. These were system defaults that we allowed to take place. The organization of PS indicates it's a physical sequential file. You can see we have our fixed block, our 100-byte record format, and then here the system has calculated the block size as 27,900 bytes. You can see we have 6 cylinders as our first extent and 1 cylinder as our secondary. In addition, on the right-hand side, you can see the creation date, any reference information, as well as how much space has been used in this particular data set. Currently, of course, it shows that 0 has been used. This is how we set about allocating and creating a new data set, and in this particular case, this is a sequential file that we could then use in order to be able to write 100-byte records into it. So from this, we can see a sequential file is one in which the records are read or written in the order in which they were created. As a result, besides the example of our disk dataset, a sequential file could also go to tape, or it could be destined for a printer. In other words, data that is written to a printer is also considered a sequential file. This may seem unusual, but when we examine how JCL is used in a later module, we will see that when we define a file as going to a particular destination, it's a relatively small change to indicate the dataset name, which can be associated with a disk, it can be associated with tape, or it can be associated with an output queue. So in all of these instances, what we can do is that by changing the JCL, we do not have to modify the program to modify the sequential file that is being created and sent to a particular destination. However, only data sets that are assigned to disk require predefined space or allocation. In summary, we have examined how data sets are structured by using the concept of records rather than being character-based. We can also group records together to allow for more efficient usage of storage devices by blocking. Naming conventions and the rules for defining datasets are largely established by installation standards, while the specific requirements for space and data characteristics will be determined by the application program for which the file is being set up. This concludes our review of datasets and sequential files. Thank you.